Welcome back to another beginner's guide to the MPCNC. So in this video I'm going to be going through my Fusion 360 workflow, how I take a CAD model and turn it into G-code, how I cut parts out of flat stock. So in this example here I've got a quadcopter frame that I modeled in Fusion 360 and I want to cut the bottom plate here out of a sheet of metal. This works whether you're cutting a sheet of plastic, a sheet of plywood. The process will be the same here. What might vary are your feeds and speeds, okay? So in this case, I have multiple components, multiple bodies here. All I want to do is cut the bottom. So I'm going to select the bottom here, right-click it, and press Isolate. And that will declutter my model to only show the part that I want. Once I've done that, I can move from the design environment into the manufacturer environment and create a new setup. I've already cut out some other parts of this, so I have some old setups here, which is why you see this other setup selected. What we're going to do is we're going to click Setup, create a new setup, and something I always do is I deselect the model here, and then I click on the model again to make sure that I know Fusion is referencing this 3D model for my stock and for my operations for this setup. Now in this case, I want my X to be to the right here, my Y to be to the back, and Z up. When I look at my work coordinate system, it's not set up that way. So instead of doing model orientation here, I'm going to select this option to pick my X and Y axis. So under X axis here, I'm going to select a vertex that's oriented in the X direction. Under Y, I'll select one that's oriented in Y, and then I'll look at this thing here and see if it looks correct. So it's upside down because the Y is coming towards me. So all I need to do is click this box here that says flip Y axis, and now that looks like it's appropriate oriented to what I want. I can go to my stock point and I'll select this front left upper corner for my stock point. And then I'll move on to defining my stock. So you can define this as a relative size box. I like to use a fixed size box, and since I know I'm cutting this out of a large sheet that is approximately 12 inches by 12 inches, I'll throw in 300 by 300 here and see, yeah, this is a big sheet and I've just got a small model that I'm cutting out. The height of my stock is actually 1.6 millimeters, which is the exact height that I modeled my quadcopter bottom as well, so I'll put that in. Now, I don't want to define my X and Y in the bottom left corner of my stock and then have my machine go cut this part right out of the center. That's super inefficient. Instead, what I'll do is I'll define that my model is offset from the left by 5 millimeters and offset from the front by 5 millimeters. Now I know wherever I set my X and Y, it's going to cut the model out right in that corner. All right. Now I don't even have to define my stock that big either. I can say that it's 150 by 120 or something like that, and I can shrink this down. The important thing here is that Fusion knows that my model is surrounded by material, okay? Because if I tell it that my material is smaller and there actually is material there, Fusion might not recognize that there's supposed to be stock there and do an operation through what it thinks is empty space and is actually a chunk of metal. So in this case, if I set it up like this, I can actually take my sheet that might be much bigger than that, and I can define my X, Y, Z 0 in different points and cut out multiple copies of this same thing, just moving my 0, 0 each time. So that looks pretty good for that. Everything looks set up. Let's press OK, and now we have a new setup. So, taking a look at our model here, we have to come up with a plan for what toolpaths and operations we're going to run in order to get this done. So I have a bunch of holes. So I know that I like to use a bore operation to bore out holes. What a bore does is it'll do a helix kind of circular entry and spiral its way down while cutting out the whole time. I've got some big holes here in the center. I could contour those out, I could bore them out, I could do some adaptive operations. I'm probably going to have to do an adaptive on this one, and then I'm going to do a contour to cut out the whole thing here at the end. I'm also going to have to do a contour on these weird kind of oval shaped motor mounting points here. So let's start off with the bore because that's the easiest. Go to 2D, press bore, I'm going to select a tool. In this case, those are pretty small, so I have a tool that I've already built here that is a 3/32 single flute end mill that's set up for aluminum cutting already. If you don't have any tools here, then what you're going to want to select is local library and press this new tool button here and define your tool. So you have to get all the cutting dimensions and stuff from the site that you bought it from, or from the manufacturer, or if you don't have any of those, just use a pair of calipers and measure and type all that stuff in. You can also put in feeds and speeds here, and the Fusion 360 software will default to those when you load that tool in. So in this case, I'll load up my aluminum cutting tool, and it already loaded in my default settings here. So I'm actually going to speed up my spindle a little bit, but keep my cutting feed the same. And what that does is reduces my feed per tooth to about just under 1 thou per tooth. And that seems to be working for me on this pretty hard 7075 aluminum. Then I'm going to go to geometry, and it says select circular faces. Okay, so I'm going to cut out that hole there, and since I have this checkbox already selected, select same diameter, it's going to find every hole of that diameter and say, yep, I'm going to cut out all of those for you. I also want to cut out these holes, so there's 4 more, and let's just have it bore out that center one as well. I could also select these, but as we can see, I have defined a spiral pattern here based on an angle. So that angle starts to become a little bit tricky when I get to really large holes like this here. So we could also change it to a pitch, and I think that will solve a lot of that problem that we have there. That looks probably pretty good. Yeah, so 0.15 on the pitch, and I'm just kind of eyeballing this. Some of these things you'll have to experiment with and see, but it looks like it's going in pretty gently, not cutting too much material at a time. We can probably do 0.2. Yeah, I think that'll work. 0.2. Cool, so now it's going to cut out all of those holes for us just using this one boring operation, and it's automatically going to link in between all of these things for us here. So let's take a look at our heights tab. And Fusion uses these heights for different things. The first one I always look at is the bottom height, okay? So what is the bottom of this job? It's the bottom of the hole that I selected. Okay, good, that's what I want. The bottom of the hole in this case is the bottom of my stock, so yeah, that's where I want it to stop cutting out. The top of the hole, right here, the top height is the hole top. Well, that's good in an ideal world where my stock is perfectly flat, my machine is perfectly flat, I did a perfect job zeroing it, but that's probably not really going to be the case. So I'm going to add a 1/2 mil to this and just have it cut a little bit of air on its way in to make sure it does a nice clean cut when it finally gets into there. So that looks pretty good. And then my retract and clearance heights here, I just want to make sure that those are going to be above any screws or fasteners or anything that I have mounted onto my flat stock. In my case, I'm going to be holding this part down with some heavy-duty double-sided tape, so I don't need to worry about anything here on the top, and 3mm will be enough clearance for me. Then under passes, we already set our pitch. We got it set to climb cutting, and that should be good. I don't think we need any finishing passes or anything like that. Now, I'm going to actually put in a small negative stock to leave value on this one, just because I know my machine, and I've done this a few times, and I think that negative 0.025mm will, which is about 1 thou, will get me a nice accurate hole of the actual size that I want to have cut out. Then here under linking, I always select preserve axial rapid, and that's because I'm running a Rambo control board that has Marlin. Marlin ignores rapid commands, so when I tell Fusion to do rapid movements, a G0 output, it'll actually ignore those G0s and it'll use the Marlin firmware defined speeds instead, which is what I want it to do for my Z axis. And for my X and Y axis, it'll use this number that I put in. So this says when it retracts, it'll use the firmware defined slow retract speed, and then it'll zip in between these operations here at 3,000 millimeters a minute, which is nice and quick. So then we'll press OK. And I always like to simulate each tool path, each tool operation each time I do it. So to do that in Fusion, it's very easy. You press the simulate button, and then you can press play. I like to make sure that the stock is turned on. I like to turn off the tool path because it's just too much clutter as you get further into there. But for this one, we can look at it. And then I'll look at the flute and have it on transparent. The default is this, and it's just a lot of stuff in your way. So you can get that all set up and then press play and watch it cut. What you're looking for here is just to make sure that it looks like it's cutting, you know, at a reasonable speed, that it's not taking like huge chunks out of this. It all depends on the material you're using. Since this is going to be aluminum, I want it to be pretty shallow. If you were using wood, you want to make sure it's not going too deep and jamming up your machine. Soft plastic, you could probably go pretty fast. Again, it all just depends on the material there. So one thing I can already see a little bit of a problem here. So this is what it did as the lead out. You can kind of see this little green radius where it finished the bore and then moved in and moved up. And it kind of crashed into this extra stock here. I'm actually going to leave that in only because this stock at this point is not actually attached to anything. It's just held on by my double-sided tape. So it'll have a little bit of give to it, and it's not going to break the tool or anything. It's just going to nudge that, and it shouldn't be a problem. It might even actually take that and launch it across the room, so be careful for that kind of thing. But you can turn off that under the linking tab here in the bore. So I'm going to pause this and press the fast forward arrow here. I'm going to turn off the toolpath, and I'm going to turn off the model and just make sure that this looks reasonable for what I expect. Cool. Again, if you want to turn off that lead out there, you can go into the linking tab and you can adjust all these linking parameters here for the vertical radius, the length, and all that kind of stuff. Alright, so I cut out all those small holes and the big hole. Next, I'm going to do a 2D contour on these contours here. So I'm going to select all of them. I'm going to make sure that this red arrow is on the inside. The red arrow is the side that Fusion is going to do the work on. So if I select it here, it's going to cut this, but it's going to cut from the outside, right? I want the tool to be in the middle here because that makes sense. Fusion does a pretty good job of guessing where you want it to be for a contour, but you definitely want to pay attention to that and always do a simulation and make sure that it did the right thing. So we got a few of these to select. All right. Then under tool, I still have my same tool, my same speeds and feeds are already set, and those will carry over from my last operation I did. That's my geometry tab. We selected the contours. I don't need any of these other options. I'll check my heights again. We're going to cut from the bottom is going to be the selected contour, which is the bottom of the model. That's good. The top height is going to be the stock top, and it's going to feed from 3 millimeters up. And that's actually going to be a little bit too high. I'm going to change that to 1 millimeter, and I'll show you what that looks like when we're done. And the clearance and retractor at 3. All right, now for passes, again, I'm going to do a slightly negative radial stock to leave just to make sure that I cut enough of this out. Axial stock to leave is how deep you want it to go. So if your machine is not cutting your parts out fully, you can actually do a little bit of a negative value here, like 0.1 or 0.05, and that'll make sure that it cuts a little deeper to get the part cut fully out. So I have it set for climb milling. I like to do repeat finishing pass as well. That helps compensate for any tool deflection to give you better dimensional accuracy. And that looks pretty good. I'm not going to do multiple depths on this one. I'm actually going to do a ramp instead. So under linking here, I have ramp selected at 3 degrees, and I'll show you what that looks like. Again, we have preserve axial rapid, 3000. And if I don't want to keep changing that, I can actually right-click on that and press make all default, and that should carry across through all of my 2D contours here in Fusion. Safe distance, lift height, I like to make that just a little bit above 0 so that it'll actually pick the tool up and not drag it across the material. And lead ins, lead outs are all the same. Looks good. So let's press OK and see what that looks like. Alright, so I can see it's doing this little contour ramp on its way in. And I got an error here. Lead out is dropped due to linking constraint. Alright, so it's not going to do the lead out because it's going to crash into the part, I think. So that's fine. I don't need to worry about that. So let's simulate. Now when I simulate, I can simulate either the whole setup or I can simulate just this contour. I'll simulate the whole setup, but I'll actually press go to next operation and skip the first one and just watch this next operation. So we'll watch our part, comes in, and it's just going to go back and forth around that little thing. Just zipping on through there and cutting them out. Looks good. Very tight squeeze. Those are only 2.5 millimeters, I think, and the tool is 2.38, so not a lot of buffer. All right, cool. Fast forward, turn off the model. Looks great. All right, so next I need to cut out this thing right here as well. So I could do an adaptive operation and mill away all of this material, which will just generate a lot of mess and stuff. But in this case, I'm just going to cut it out with a contour. It's all going to be double-sided taped down, so I'll just leave a little plug basically here in the middle. That's the shape of this thing. I think that'll be the least amount of work on the tool and still get us a good finish. So I'll select 2D contour, and I'll select that contour. Make sure my red arrow is on the side that I want it to be. We've got our tool selected here with the same feeds and speeds. We'll select our heights, and those are all set, feeding from 1 millimeter. Now for passes, we can do multiple depths if I want this to go, like let's say 1/4 of a mil and 1/4 of a mil, and just kind of keep working its way down. I'm actually just going to do a ramp instead, and I'm going to make it very shallow. So it's going to be kind of like a boring operation, but on a non-circular shape. I think that'll just keep the tool engaged the same amount the whole way that it goes down, and should cut this out and make it look pretty good. Keep my negative radial stock to leave. I'm going to do a repeat finishing pass. So we'll do the repeat finishing pass. That'll make it nice and clean. And then over here on linking, we need to figure out the ramp angle. So I'm going to start with like 1 degree, and we're going to see what that looks like. Alright, so that looks a little bit aggressive. It's giving me an error for lifting plane. Yep, that's fine. So let's take that down to 1/2 degree maybe and try it again. Maybe still a little bit aggressive for what I'm doing in this aluminum. So I'm just kind of guessing and checking here as I work down. And yeah, that'll probably work. Let's just go a little bit smaller just to be safe. Too little tool engagement just kind of wears down your bits faster, but I'll probably crash this bit into something and break it long before it wears out, so I'm not really worried about that. Alright, so that looks pretty good. Let's simulate again. Skip the first two, turn off the model, and watch this move in. And let's just fast forward until it's going to hit. Yeah, so it's just kind of ramping the whole way down. A little bit of engagement there, and it'll cut this whole thing out. Looks great. Again, I did this little linking lead out, but in this case, I'm okay with it. Alright, so I liked that, and I want to do that one again, but I want to cut out the whole thing on the outside here. So what I can do is I can actually duplicate this job and then just select a different contour. So I'll take this contour chain, close it out, and I'll select the outside contour and press OK. And all my settings should be exactly the same. Now this thing is so wide that this ramp is not actually going to work. That's not going to be a really effective strategy for this one. So I'm going to turn the ramp on to 3 degrees, but I'm actually going to do multiple passes here under multiple depths. So I'm going to say multiple depths, 0.45 millimeter, and I'll tell it to use even step downs and see what that looks like. Cool, so we can see we've got 4 different cutting depths here, and it's ramping, which means that it's going to kind of slowly work its way into the material instead of just plunging right in. So again, we will simulate and watch this last operation go. So it ramps into it there, starting out shallow, and then going to the full depth, and then it's just going to cut out the whole part. Now, this works well cutting out the whole part like this because I'm going to have this whole thing taped down. So once it's done cutting, the part is still stuck to the bed because there's going to be double-sided tape all underneath of it here. But if you're using clamps or screwing a piece of plywood to your machine or something like that, you do not want to cut it all the way out like this because as soon as it gets about halfway done, the part's going to start to get loose and it's going to probably ruin your part. So instead, what you're going to want to do is you're going to want to edit this contour and add tabs to your contour. So you do that under the geometry tab of a contour. You click the tabs check mark, and it will put tabs on here to keep this part attached. And you can mess with them. You can make them wide, you can make them narrow, you can make them thinner or thicker, and adjust the spacing however you like. Basically, the more tabs there are, the more secure the part will be, but the more work it's going to be to clean it up when you're done. I don't really like having tabs on round parts like this, just because it is harder to make them cleaned up. So you can actually just do it at points instead of at a spacing, and I can put one there, something like that. Maybe I want ones on either side of this. And I'm just going to press OK and show you what that looks like in the simulation, even though I'm not actually going to use tabs. So it'll run through. Let's turn off our model as well and make sure it looks correct. And then as it gets down here, it's going to start skipping over those tabs. And you'll see that those are still connected. So when we're done, our part will still be attached to the main part of the stock that is clamped down or screwed down to our spoil board. And all you need to do is pop that out, cut those off, sand them down to make it look smooth, or whatever you need to do to finish off your part. So that's it. That's how you can use Fusion 360 to cut out a part from flat sheet using some contour and some boring operations. If you are using flat sheet, I recommend doing the contours like this. You can do adaptives and kind of cut all of this material, but it's going to make a big mess and might not be necessary. If you don't use double-sided tape or something like that, and you want to cut this out kind of the way that I've cut it out here, where we have like this little island in the middle here, I would also add tabs to these as well. So the borer cuts all the material. You might want to use a contour instead of a bore for these interior ones. That way you can add tabs. But if you're just clamping your material and you don't put tabs on here, these things will get loose, and they may or may not stay there. They might fly around. They might crash into the bit and cause some problems with your work. So just some other things to consider. I hope that video helped, and take care.